Hi, this is Sonia Doucette. In this video, I'll show you how to find the unknown concentration of an acid by using data from a titration. So this problem says that a 25 milliliter sample of acetic acid is titrated with 0.200 molar sodium hydroxide to the equivalence point at 94.7 milliliters sodium hydroxide. So that just means that the equivalence point was reached when 94.7 milliliters of sodium hydroxide was added. What is the molarity of acetic acid? So you're titrating the acetic acid in order to find out its concentration. Its concentration is unknown at this point, and that's the whole reason for doing a titration, to find out the concentration that is not known. So one thing you need to know about titrations before you go ahead and try to do calculations is that at the equivalence point, the moles of hydroxide are equal to the moles of hydrogen ion. So you might be asking, well, why do we care about that, and how can we relate that to what we're specifically dealing with in this problem? Well, what happens when the acetic acid, the CH3CO2H, when that dissolves in solution or dissociates or ionizes, whatever you want to call it, it ionizes into an anion and a hydrogen ion. So this was what that would look like. You have CH3CO2H acid, and it will dissociate into the acetate anion plus the hydrogen ion. So that's where the hydrogen ion piece comes in. And then what you also have happening is that you'll have the sodium hydroxide, which is also in aqueous form, dissociate into a sodium cation and a hydroxide anion. So that's where the hydroxide piece comes in here. So what you have when you're titrating is you have some amount, in this case 25 milliliters, of the acetic acid sitting in a beaker, and you're slowly adding sodium hydroxide, which is called the titrant, to the beaker until you reach the equivalence point. When you reach the equivalence point, you stop adding the titrant, in this case that's sodium hydroxide, and you record the volume of titrant that has been added by the time you reach the equivalence point. So in this case, that volume is 94.7. So knowing all that, what you can actually say is that for every 1 mole of hydroxide that's added, 1 mole of the hydrogen ion is neutralized, because what you have happening here, when the acetic acid and the sodium hydroxide get into solution and ionize, you have the proton reacting with the hydroxide ion to neutralize it, and water will form from that reaction. So after a while, the equivalence point is really the neutralization point, because at that point, those concentrations are equal to each other, which means you have a neutral pH in this case. You have water formed. So knowing all that, you could start by asking, in order to find the concentration of acetic acid, you could ask how many moles of hydroxide are added or have been added by the time you hit that equivalence point. You can do that by multiplying the volume at the equivalence point by the molarity of the titrant. So in this case, we'll go and we'll take 94.7 milliliters of NaOH, and we need to convert that to liters, because if we want to multiply it by molarity, you have to be in liters. And then you multiply by the molarity. So the molarity of the NaOH is 200 moles of NaOH per liter. So liters will cancel, milliliters will cancel, you'll be left with moles of NaOH. So at the equivalence point, you have added to the solution 0.01894 moles of NaOH. So you know, because of this balanced chemical equation, that for every 1 mole of NaOH you add, you're going to get 1 mole of OH. So that means that at the equivalence point you also have the same number of moles of OH as you have moles of NaOH. And then for every, as I mentioned with this neutralization reaction here, for every mole of OH you add, you're going to neutralize 1 mole of hydrogen ion. So that means that you have also 0.01894 moles of the hydrogen ion at that point. It should be moles. And then if you look back to the equation showing the ionization of acetic acid, you can see that the relationship between protons and the actual acetic acid is also 1-to-1. So that also means you have the same number of moles of acetic acid. That should be a 2 present. So now, essentially, you know the moles of acetic acid that you have. If you know the moles of acetic acid, and if you look way back up here and realize that you also know the initial volume of the acetic acid, all you have to do is divide the moles by the volume, and that will give you the molarity of your acetic acid, which is what you're trying to solve for. So all you have to do is take that 0.01894 moles of acetic acid and divide it by the volume. So the volume in this case is in milliliters, so you need to convert that to liters. And what you'll get there is 0.758 molar CH3CO2H. That is the molarity of acetic acid.